We live our lives through these amazing little devices, all powered by tiny, almost magical pieces of silicon. But here's the thing. Behind their clean digital promise, there's a hidden environmental story. In this explainer, we're going to pull back the curtain on the real ecological footprint of the microchip.
Yeah, just look at the phone in your hand or the laptop you might be watching this on. They look so sleek, so efficient, so clean. But what if I told you that creating their electronic brains is one of the most resource-intensive, dirtiest manufacturing processes on the entire planet?
Because the journey of just one of those tiny chips is this massive, globe-trotting saga of mining, manufacturing, and ultimately, waste. We're about to follow that journey, and it's probably going to challenge everything you think you know about clean tech.
So for the longest time, whenever people talked about chips, it was all about one thing. Can we get enough of them? It's all been about geopolitics, supply chains, and economic security. And all that noise has pretty much drowned out a huge, inconvenient truth: the massive ecological problem they create.
Okay, so let's start at the beginning. The environmental damage from a chip, it starts way, way before anyone even flips a switch in a factory. To really get it, you have to look at the incredible and incredibly dirty journey of its raw materials. And just to give you a sense of scale here, check this out. The components that go into a single chip travel over 50,000 kilometers. They cross international borders more than 70 times. It is a truly planet-spanning operation before one chip is even finished. So where does that 50,000-kilometer journey begin? It starts deep in the earth, with mining. We're talking about essential stuff like palladium, copper, and cobalt. And digging them up often means destroying habitats, polluting water and soil, and using just enormous amounts of energy. All right, so after all that mining and traveling, the materials finally get to the factory, or the fab, as they call it in the industry. And this is where the environmental cost just skyrockets. This next stage is where the real consumption begins. Okay, brace yourself for this number. A single large chip factory can burn through up to 38 million liters of water every single day. And most of that is for creating the ultra-pure water needed to keep the chips perfectly clean during production. I mean, it's hard to even wrap your head around that much water, right? So let's put it this way. That is the same amount of water used by an entire city of 300,000 people. The thirst of just one factory matches a whole city. It's wild. Okay, so that's the water. But what about the electricity? Well, if the EU hits its goals for chip production, by 2030, the industry is expected to be eating up 47.4 terawatt-hours of electricity a year. This right here is the #1 source of its greenhouse gas emissions. And if that number doesn't sound massive on its own, think about this. It's about half of what all European data centers are projected to use. You know data centers, the industry we always talk about as being incredibly power-hungry? This is half of all of them combined. And inside these factories, it gets even worse. To make the chips, they use this chemical cocktail of fluorinated gases. And their global warming potential, it's just off the charts. We're talking about gases that are thousands, sometimes tens of thousands of times more potent than CO2. And some of them, like CF4, will stick around in the atmosphere for 50,000 years. A lot of these chemicals belong to a group you've probably heard about on the news, PFAS, forever chemicals. And they're called that for a reason. They just don't break down. Not in the environment, not in our bodies. They just build up, creating this massive risk of contamination that we can never undo.
So the obvious question is, why not just stop using them? Find something safer? Well, that's the tricky part. It's not that simple. Finding, testing, and then rolling out safer alternatives across this incredibly complex industry, it's a huge challenge. We're talking about a timeline of decades, not years.
So we've established that making chips is a really dirty business. But here's the kicker. Governments all over the world, like the EU with its big CHIPS Act, are pushing to do more of it. A lot more. So what's that going to do to the climate?
Yeah, the projections are not great. Take a look. Even in the absolute best-case scenario, where the industry magically runs on 100% renewable energy, emissions are still set to quadruple by 2030. And if it's business as usual, they could go up by 8 times or more. And that unit MMTCE is just a standard way to measure all the different greenhouse gases together.
So what does that really mean? It means Europe's chip industry could soon be polluting on the same scale as its entire chemical industry, or its steel industry. We're literally building a brand new heavy polluting industry, all in the name of digital progress.
But the story doesn't stop when the chip leaves the factory.
After all that work, all those resources, what happens at the end of the line when we're done with our gadgets? Well, it all becomes part of a huge and fast-growing mountain of e-waste.
By 2030, we're on pace to be turning out 75 million tons of electronic waste every single year. And that's all driven by us, right? Our need for the next new thing, and the fact that our devices just don't last as long as they used to.
And the really grim part? Look at where it all ends up. Less than 18% of it, that little slice right there, is actually collected and recycled properly. The vast majority, it just gets dumped or burned, leaching all those toxic materials back into the environment.
So all of this brings us back to a really tough question, doesn't it? We all want a digital future, and we absolutely need a green future. But what if, right now, those two goals are actually fighting against each other?
And this, right here, is the huge paradox of what policymakers are calling the twin transition. The very technology we're counting on to build a greener world, from electric cars to smart energy grids, is built on a foundation that is fundamentally, deeply environmentally destructive. And figuring out how to solve that contradiction, that might just be the biggest challenge of our time.